Have you ever looked up at the night sky and wondered, what if, somewhere out there, there's another version of you? A you that took that job offer. A you that never left your hometown. A you that learned to play the guitar. What if every choice you ever made didn't just disappear, but instead created a whole new world? This isn't just a question for science fiction anymore. It's a question that some of the brightest minds in physics are asking. Are there parallel universes? And could science actually prove it? To even begin this journey, we have to redefine a word we think we know: universe. For centuries, the universe meant everything, the whole shebang. But in modern physics, that definition is getting an upgrade. Our universe might just be our observable bubble of space-time, everything we can see from Earth, limited by the speed of light and the age of the cosmos. So, when scientists talk about a multiverse, they're not necessarily talking about fantasy. They're talking about the bigger reality that might exist beyond our cosmic horizon. Our first clue comes from the most explosive event in history: the Big Bang. In the first trillionth of a second, the universe didn't just expand, it inflated, growing faster than the speed of light. This is the theory of cosmic inflation. But what if that inflation never completely stopped everywhere? Cosmologists like Alan Guth and André Linde proposed a mind-bending idea called eternal inflation. They suggest that while inflation stopped in our pocket of space, allowing stars and galaxies to form, it continued raging on in other regions. These regions kept inflating, spawning new, self-contained bubble universes. Each bubble could be a cosmos of its own, potentially with completely different physical laws, different fundamental constants, and maybe even a different number of dimensions. In this view, our universe might be just one bubble in an infinite, bubbling cosmic foam. But the clues don't just come from the cosmos. They come from the impossibly small world of quantum mechanics. You see, at the subatomic level, reality gets weird. A particle, like an electron, doesn't just have one fixed position until you look at it. It exists in a cloud of possibilities, a state called superposition. In 1957, a physicist named Hugh Everett proposed a radical explanation for this. His many worlds interpretation suggests that when we observe a particle and see one outcome, the universe doesn't just pick one path. Instead, reality itself splits. Every single possible outcome of that quantum event actually happens, each in its own separate, branching universe. Think about it. In one universe, you turned left this morning. In another, you turned right. In one, you took the job offer. In another, you didn't. According to this theory, both versions of you exist, equally real. The universe doesn't choose, it multiplies. Now, let's add another layer of complexity. For decades, physicists have been trying to unite all the forces of nature into a single theory of everything. One of the leading candidates is string theory, and its more modern cousin, M-theory. These theories propose that the fundamental building blocks of reality aren't point-like particles, but tiny, vibrating strings of energy. But for the math to work, string theory requires more than the 3 spatial dimensions we know, plus time. It predicts the existence of up to 10 or 11 dimensions. So where are these extra dimensions? The theory suggests they could be curled up, too small for us to see, or they could be vast, hosting entire universes. In this model, our universe could be a giant 3-dimensional membrane, or brane, floating through a higher dimensional space. And it might not be alone. Other branes, other universes, could be floating right alongside ours. Imagine cosmic sheets, rippling through a higher dimensional ocean. Some physicists even speculate that a collision between 2 of these branes could be powerful enough to trigger a new Big Bang, giving birth to a new universe. This all sounds incredible, but is there any way we could actually detect these other universes? While we can't just hop in a spaceship and travel to another bubble, scientists are searching for indirect signs. One place they're looking is the cosmic microwave background, or CMB, the faint afterglow of the Big Bang. If our universe ever collided or bumped into another bubble universe in the distant past, it might have left a bruise, a cold spot, or an unusual pattern in the temperature of the CMB. And intriguingly, astronomers have found some of these anomalies. Another potential clue could come from gravitational waves. These ripples in space-time, first detected in 2015, travel across the cosmos. It's possible that gravitational waves from an event in another universe could leak into ours, carrying faint signatures of a reality beyond our own. So far, there's no smoking gun, no definitive proof. But the intriguing patterns are there, keeping the search alive. Of course, the idea of a multiverse forces us to confront some deep philosophical questions. If there are infinite versions of you, living out every possible life, what does that mean for your identity? Does choice still matter if every option you could possibly choose is being acted out somewhere? It introduces a concept you might call the cosmic self, the idea that your individual identity is just one branch of a much larger universal pattern. Maybe you aren't just this one person in this one life. Maybe you are the sum of all your possibilities. Perhaps we are not just in the universe. The universe is in us, branching and exploring itself through our every decision. Connecting this ancient question to our modern age, some thinkers have even proposed the simulation hypothesis. Could our universe, and countless others, be digital realities running on some vast, unknowable computer? This computational multiverse is a fascinating idea, and emerging technologies like AI and quantum computing could one day play a role. AI could help us sift through massive data sets from the cosmos, searching for the subtle patterns that might hint at other universes. Or, we might one day use quantum computers to simulate the birth of universes ourselves, testing whether the laws of physics naturally lead to a multiverse. It's important to be clear. This is the cutting edge of science, and there's a vigorous debate happening right now. Many physicists remain skeptical. They argue that because these other universes are, by definition, separate from ours, we can never directly observe them. And if a theory can't be tested or falsified, is it really science, or is it just philosophy? It's a valid criticism. But defenders of the multiverse argue that these ideas aren't just wild fantasy. They are the natural, logical consequences of our best, most tested theories, like cosmic inflation and quantum mechanics. From this perspective, science's job is not to limit imagination, but to follow the evidence and test the consequences, no matter how strange they seem. So, where does that leave us? Whether the multiverse is ultimately proven true or not, the very idea has changed how we see ourselves and our place in the cosmos. It pushes the boundaries of human knowledge and forces us to be humble. If infinite universes exist, then life, consciousness, and the search for meaning may not be cosmic accidents. They may be inevitable outcomes, guaranteed to arise somewhere in the infinite tapestry of possibilities. Perhaps the universe isn't just one story, but an infinite library of stories. And somewhere in that library, every version of you exists, looking up at their own night sky, wondering, just like you are now, if it's all real. Thanks for joining me on this journey through reality. If you enjoyed this exploration, don't forget to like, subscribe, and hit that notification bell to keep up with our latest videos. See you next time.